This lesson deals with Supplemental Problem 6.3. You can find this problem in the course ebook in the Chapter 6 Supplemental Problems on page 3. In Chapter 6, around page 19, we introduced what's called a second-order low-pass filter. We use the word second order to refer to the fact that we've got two reactive elements. Let's see if this is a low-pass filter. When the frequency gets lower and lower, the inductor approaches a short circuit, and the capacitor approaches an open circuit. With a short circuit, the output equals the input, and so it does pass low frequencies. Now, as the frequency goes up, the capacitor looks more and more like a short circuit, and the inductor more and more like an open circuit. The short circuit is shorting out the output, and the open circuit here is letting less current come in, which eventually flows into that short circuit and creates an actual drop. There's two things that are pulling us down as frequency goes up, and we saw in around page 20 of Chapter 6 that the slope was double that of a one capacitor or one inductor low-pass filter. In other words, minus 40 dB per decade. This does look like a second-order low-pass filter. Could you solve for V out over V sub S, and then use that to find omega naught and Q naught? Well, we have a voltage divider of this impedance with this one. Well, the impedance here will be product over sum, so 1 over j omega c times R divided by R plus 1 over j omega c, voltage divided with omega L. Let's multiply numerator and denominator by j omega c. This term becomes just R. We have j omega c times R, and then that would cancel with this negative 1. Likewise, in the denominator, j omega c multiplying through here just gives us R, and then this gives us j omega c times R, and this term becomes just 1. Now let's multiply through by the denominator of this term, which is j omega c R plus 1. On the numerator, I just have R. In the denominator, cancels this, I just get R. And now I multiply this by this term. I'm going to get j omega L times j omega CR. I get a j squared, which is a minus sign, and an omega squared, and then an L, and then a C and an R. And multiplying this term by this, we just get j omega L. Let's divide numerator and denominator to get it to look like the general form we found in Chapter 6, page 19. Dividing by R, I have a 1, and a 1 here. And then I've got minus omega squared LC cancels with the R, and then I have j omega L divided by R. Now, is that the form of a second-order low-pass filter? Well, it does. Here's my term 1 over omega naught squared, and here's my term omega naught Q naught embedded in that term. So comparing terms then, omega naught squared is going to be 1 over LC. Omega naught is 1 over square root of LC. And the term omega naught Q naught is going to be equal to R divided by L. Q naught then is R over L divided by omega naught, but omega naught is 1 over square root of LC, so the reciprocal of that's right here. And you could write this as the square root of L squared. This L cancels with one of these, and I just have R times the square root of C divided by the square root of L. And this is Supplemental Problem 6.3.